the physics of elevators. Why you feel heavier going up and lighter coming down, elevators create a curious sensation, a fleeting shift in how heavy you feel. Whether rising or descending, the floor beneath your feet seems to exert a different force. But what's actually happening? The answer lies in understanding the difference between mass, gravity, and the feeling of weight. The illusion of weight. Most people assume weight is a constant. In everyday life, it is. However, inside an elevator, the physics change. When the elevator accelerates, whether upward or downward, you briefly feel heavier or lighter. This isn't about your actual mass changing, but about how hard the floor is pushing back against you. The key distinction is between gravity and the normal force. Gravity is the constant pull on your body, while the normal force is the upward push from the floor preventing you from falling. A scale measures the normal force, not gravity directly. Why astronauts feel weightless? To understand this better, consider astronauts in orbit. They aren't escaping gravity. Earth's gravitational pull at the International Space Station's altitude is still around 90% of what it is on the ground. They feel weightless because they are in constant freefall. The space station moves sideways at over 17,000 mph, constantly falling toward Earth, but missing the ground due to Earth's curvature. Because the floor isn't pushing up against them, astronauts experience zero normal force and thus weightlessness. Elevator acceleration and deceleration. Elevators mimic this dynamic in miniature. When an elevator starts rising, it accelerates you upward. To do this, the floor must push harder than usual, making you feel heavier. Conversely, as the elevator slows down at the top, it decelerates, meaning the floor pushes up less, making you feel lighter. The opposite happens when descending. Acceleration downward makes you feel lighter, while slowing down at the bottom makes you feel heavier. These shifts in force are subtle but measurable. A person weighing 150 pounds might briefly register around 165 pounds on a scale during upward acceleration. The difference is about 10%, but noticeable. The connection to modern physics, the sensation of weight, isn't just about gravity. It's about the interaction between gravity and the supporting surface. Elevators demonstrate this principle in a simple, everyday way, linking to the fundamental concepts governing motion and force in physics. This experience reveals that we don't actually feel gravity directly, we feel the resistance to it. This realization bridges the gap between an elevator ride and the complex mechanics of space travel.